Word systems. What do you think of? More than one thing. I like that. That is great. So we're looking at in mathematics more than one equation, right? So we've been studying how to um, graph the past couple days, right? Graph a line, which is y equals mx plus b. Okay. Now, when we're graphing two lines, think about it, two lines, um, we're going to have three scenarios, right? Three different scenarios. Scenarios. Okay. So the first scenario is what? Think about two lines. Think about what can happen with two lines. Two lines. Two lines. What can happen with two lines? Intersect. Great, Antonio. So intersecting lines. I got one line here, and say I got another line here. By the way, what? Yes, sir. Ooh, that's the second one. Okay, I'll write it down, but then we're gonna. I want to come back to it. Okay, parallel. Let me talk a little bit about intersecting first. Okay. So intersecting lines. By the way, what is a line? What is it? What's a line? Antonio.
2 points that connect together.
Yes, 2 points do make up a line because they're showing location, so you can draw the line. But how many points are in a line? Infinitely many, right? In fact, that's a definition in geometry from like day number two or even day number one. They tell you a line is made up of infinitely many points, right? Well, those points on any line. Okay, say this equation for this line. Now remember, we've been working with equations of lines, right? Say this equation is y sub 1 equals mx of 1 plus b sub 1. And the equation for this line is y sub 2. And I'm using different subscripts, right? So it's telling you these two lines have different equations. So y sub 2 equals mx2 plus b2. So each one of these lines have an equation. Now, if for this equation, any one of these points, there's infinitely many, right? Any one of these points is going to make this statement true. It's going to work for this equation, right? Each point has an x coordinate and a y coordinate, right? So this point, if I plug it into this equation, it's going to make this equation true. If I plug in the x for here, the y for here, it's going to make that true. Same with this equation. Okay? If I go ahead and take each one of these points, the xy coordinate, and I plug in the x for this one and the y for this, it's going to work in this equation. So with systems of equations, I want that point that works in both of these at the same time, which is going to happen to be the intersecting point. In fact, there's only, thinking back to geometry, when two lines intersect, they have exactly 1 point in common, right? So this one is going to have exactly one solution that works in both of these equations. Makes sense. It's going to be the coordinates of this point, x comma y. And I wish that we would be teaching this when you go through algebra and geometry, so you guys can, you know, fit things together. We have a tendency, or not a tendency, we do teach algebra separate, geometry separate, algebra 2 separate. All of these things do intertwine. We just don't really teach you that. Geometry and algebra 2 are very much intertwined, and this is the reason why. Okay. Um, well, I'll post this on Google Classroom for you guys. Okay. I've been actually catching up, so I should be all caught up today. Yeah. All right, parallel lines. Now, Antonio, you told me about parallel lines. Okay, so parallel lines never intersect, right? Geometry. Parallel lines never intersect. So if they never intersect, how many solutions are there for this, the equation of this line, and then the equation of this line? And again, I'm using different subscripts to denote that they're different equations. Do I have anything in common between these two equations or lines? Is there a point that will work? If I pick a point on this line, will it work in this equation for this line? No, no, there's no intersection point that will work in both, right? So in this case, there are, if I have parallel lines, there will be no solutions. Yes, sir.
So, don't parallel lines also mean they have the same slope?
Yes. Good. You're ahead of me again, but great observation. Same slope. I was going to try to trick you guys up later. Keep that in mind when I do that. So they're going to have the same slope. By the way, um, what other slope did you learn that had a special quality? Do you remember? Anybody remember?
Oh, if there is no slope, it's just up and down or straight across.
Well, true, true. Yeah, we talked about that yesterday, right? Horizontal line has zero slope, vertical line undefined. I was getting at negative reciprocals, remember? Procals. I think this is the way you spell it. I can't remember. Where you have like negative one half for the slope of one equation, and then the other equation you'll have positive two, negative reciprocals. These you have right angles, right? So if they have right angles at their intersection, you know they're going to have exactly one solution. So you could save yourself a whole lot of time if you guys remember these. And we'll show you when I do the examples. Um, this will come up. Okay, so if you have parallel lines, algebraically, algebraically, you'll get something like two equals zero, you know, four equal two, something that's not true algebraically. Then you know you have no solutions. Okay? Exactly one solution, you're going to get that whatever one you solve for, you're going to get x equal a number and y equals a number algebraically. There's a third scenario, right? It's a third scenario. Anybody remember?
They're the same line.
The same line, right? The same line. In other words, I have a line, and then I have another line that's right on top of this, right? The same line. How many points do these lines have in common?
they're in.
Infinitely many. Good. Yeah. Every single point, no matter what I pick, it's going to be a solution for both of these equations. So infinitely many. Okay. You guys are going to have to write these down too when they pop up for systems. You either have to put infinitely many solutions, no solutions, or the ordered pair itself. If you don't, you got to take a little bit off. We're in algebra 2 now. So those are my three scenarios when we start working with systems of equations, right? I'm already zoomed all the way out. So it's going to be one of those three. Now, to figure out which scenario we're in, you're going to choose. We have three different methods to determine what scenario we're in. Okay. So it's a little confusing. Three different methods for three different scenarios. If you go to your note packets, that's what this means up here. Okay. Three methods: graphing, which is what we're going to do today, substitution, and then elimination. We're going to work on just the graphing today. And this is why I had you guys like review graphing lines past couple days, because that's exactly what we're going to do here. We're going to graph each one of these lines and see which scenario it fits into. Okay. All right. So let's graph number one. Let's graph this line. And what do we do first? The y-intercept, right? What's the y-intercept? Great. What's the slope? 1 over 2 or negative 1 over negative 2, right? So let's graph that line. See, I start negative 2, and I go up 1 over 2, up 1 over 2. And if I use the negative, I could go down 1 to the left 2. Now this is where it helps to graph to plot a lot of points. Because if they intersect, I'll easily can tell where that ordered pair is. Okay, next one. My y-intercept, slope, or 2 over negative 1, right? Okay, so I start at 3 on the y-axis. I'm going to use this one because I want to get close to that line and see if it intersects or where it does. 1, 2 to the right 1, down 2 to the right 1. So there's my point of intersection. Did I?
No, I'm looking at mine. I think I went the wrong direction.
Yeah, you got to be careful with that minus sign. So they do intersect. In fact, they intersect at the point, see, positive 2 for x and negative 1 for y. There's my solution. It has exactly one solution. And you have to put down the ordered pair. Bless you. All right. Okay, number 2. Let's graph this line. Let's see, my y-intercept is 2. And what's my slope? Good. Or negative 2 over negative 1, right? So start at 2 on the y-axis. We could do up 2 to the right one, or go down 2 to the left one. I'm going to put a bunch of these in there. Down 2 to the left one, down 2 to the left one. So there's my line. Okay, next one. What's my y-intercept? What's my slope?
2/1 or -2.
And Asher, what kind of lines am I going to have?
Intersecting. No, parallel.
Parallel, right? Same slopes. So I could save myself a whole bunch of work. Down 2 to the left one, right? Down 2 to the left one. Down 2 to the left one. I could have not even done this problem if I would have looked, well, done the algebra. If I would have looked at the problem and noticed the same slopes, I could have just gone from here to here, not even graph it, do all this other stuff because they had the same slope. See what I mean? If you remember just these couple of things, and if you don't, it's no big deal. I mean, go through the work and you find that it's just a shortcut. If they have the same slope, it's going to be no solution.
So it's like that, you see no solution?
Yep, circle, same slope, so I know that you are saying no solution, not just guessing. Circle the slopes and put no solution, and you won't have to do all this work. All right, number 3. Number 3 got me last hour because I made a mistake and I couldn't figure it out. All right, the second equation here in number 3, x equal 1. What kind of line do I have? Vertical line at x equal 1, right? So I have a vertical line at x equal 1. Okay, now notice what form is that in? Standard form, right? Standard form, how did we graph lines in standard form yesterday? We did the x-intercept where y equals 0, right? So we would have x minus 0 equal 3. So here, x equal 3, or the point 3 comma 0. So we have the point 3 comma 0, the x-intercept. The y-intercept, almost the same thing, right? Except this one, the x equals 0. So we have 0 minus y equal 3. I have to get that negative sign over here, so I'm going to divide by -1, and I get y equals -3, or the point 0, -3. So 0, -3. This one I'm going to have to use a straight edge because I want that exact point where they intersect. And they intersect at what point?
1, -2.
1, -2. Now, back in Algebra 1, they probably didn't have the standard form, right, using the x and y intercepts. What did you have to do in Algebra 1? You remember? It kind of made you put this in slope intercept form, right? In other words, you isolated the y or solved for y. Remember 1.4 part 2, why we did that section before this? We have the equation x minus y equal 3, and we want it in this form. So we want to get y by itself. So I'm going to subtract x. I get negative y equals, and I'm going to put my x term first, negative x plus 3. Then I divide by negative 1 every term. Didn't they make you do this in Algebra 1? So I get my y equals, now there's a 1 there, right, with the x. I got negative 1 over negative 1, or just 1 over 1 x. Positive 3 divided by negative 1 is negative 3. That's where I made my mistake earlier. So my y-intercept is negative 3. My slope is 1 over 1, or negative 1 over negative 1. And I'm going to graph this. So negative 3 and up 1 over 1, and it happens to be the same line. Okay? So either method or either way you want to figure out how to graph this line, it's up to you. This can get pretty tricky solving for isolating the variable. If you're accurate enough, use the intercepts, but you got to use that straight edge. Otherwise, it's going to float and you're going to be trying to figure out what the fraction is. One more, because I know how much you guys. So, which one do you want to do? Do you want to do XY intercept, or do you want to solve for Y? It's up to you. Majority rules. Find the X and Y intercepts. How about we find the X and Y intercepts for this line and do the other one for that one? Okay, so let's find the X and Y intercepts. X intercept, set Y equal to 0. So I get X plus 0 equal 4. So I get 4 comma 0. Y-intercept, I'm almost done. And I'm tired of listening to myself too.
No, I'm so sorry.
No, it is. It's a lot to decipher. I set x equal to 0, so I get 0 plus 2y equal 4. Divide both sides by 2. So y equals 2, or 0 comma 2. 0 comma 2. I'm going to use straight edge. And then this one, I'm going to put in y equals mx plus b form. So I'm going to solve for y. I have 3x plus y equals negative 3. I'm going to subtract 3x from both sides. And I get y equals negative 3x minus 3. So my y-intercept, negative 3, slope, negative 3 over 1 or 3 over negative 1. Graph that line. Let's see, negative 3. And I'm going to use positive 3 so that I go up. So positive 3 to the left 1, positive 3 to the left 1, and there's my point of intersection, right? Negative 2, comma, 1, 2, 3, 3. Now, in delta math, week 5 has one section of solving systems by graphing. Okay, that's the section you can do now. So do the section of systems by graphing. So systems by graphing. Okay? And actually, there's not too many problems. You probably will get them done now if you do them. Any questions on this?